This is a phone, an ordinary iPhone, on airplane mode, no internet at all. And right now it's running a 27 billion parameter AI model, completely on device. No GPU, no cloud, no subscription. A year ago, that sentence was science fiction. Here's why that's wild. A 27 billion parameter model, in normal 16-bit precision, weighs about 54 gigabytes. Even a good 4-bit build is 18. Your phone hands a single app, maybe 6. The math simply doesn't fit. Look at the gap. 54 gigabytes at full precision, 18 at 4-bit. And the memory your phone actually gives a single app on a 12-gig iPhone is around 6. For years, that gap is why the big models lived in data centers. This is Bonsai 27B. It's the full Qwen 3.6 27B model, squeezed down until it fits in 3.9 gigabytes and runs on the phone already in your pocket. Same model, a fraction of the size. The name fits. Think of a bonsai tree. It's not a different tree, it's the whole thing, pruned to miniature. Same shape, same branches, tiny footprint. That's what they did to a data center model. 54 gigabytes, down to under 4. 3 parts. How you fold a 54 gig model into under 4, what it costs you in quality when you do, and how to run the thing on your own phone today for $0. Screenshot that. Let's start with the trick. The trick is brutal simplicity. A normal weight uses 16 bits. Bonsai's 1-bit build stores each weight as basically a single sign, -1 or +1, about 1.125 bits each. Ternary adds a 0, 3 values, 1.71 bits. So you get 2 builds. The 1-bit version lands at 3.9 gigabytes. The ternary version, a touch more precise, at 5.9. Both small enough to sit on a phone with room left over for the actual work. And this isn't a half measure. The low-bit weights run end-to-end, embeddings, attention, the MLP layers, even the output head. There's no secret high-precision layer hiding inside to prop it up. The whole network went tiny. Each weight also carries a small shared scaling factor, so those crude -1s and +1s still land in roughly the right place. That's the whole game. Strip the precision down to almost nothing. Keep just enough structure to stay smart. Put the sizes side by side. 54 gigabytes full, 18 at 4-bit, 3.9 for 1-bit Bonsai. That last drop is the one that moves a model off a server rack and onto a device you actually own. There's a cleaner way to say it. Intelligence per gigabyte. 1-bit Bonsai delivers about 0.53 points of benchmark score for every gigabyte it uses. That's more than 10 times the full precision model, and roughly 2.7 times the next best low-bit build. Speed holds up too. On an RTX 5090, the 1-bit build runs at 163 tokens a second, 134 for ternary. Fewer bits to move means less memory bandwidth burned, so tiny can actually mean fast. Off the big GPU, it still moves. On an M5 Max laptop, about 87 tokens a second 1-bit, 58 ternary. And on an iPhone 17 Pro, reports put it near 11 tokens a second. Not blazing, but genuinely usable on a phone, offline. It's not a toy, either. Full 262,000 token context. It's multimodal, with a compact 4-bit vision tower, so it reads screenshots, documents, and your camera. All of that, running locally, on the device in your hand. Okay, but does shrinking it make it dumb? Here's the honest scoreboard. Across 15 benchmarks, the full precision base scores 85. Ternary Bonsai scores 80.5. 1-bit lands at 76.1. As percentages, that's ternary keeping 95% of the original's ability and 1-bit keeping 90. You threw away roughly 15/16 of every weight and kept 90% of the smarts. Sit with that for a second. It holds up best where you'd hope. On math, grade school through competition problems, the full model scores 95.3. Ternary, 93.4. 1-bit, 91.7. The reasoning barely flinches. Coding stays strong too. 88.7 at full precision, 86 for ternary, just under 82 for 1-bit. For something living entirely on your phone, writing usable code, that's genuinely hard to believe. Vision takes a bigger hit. 72.6 down to 65 for ternary, and under 60 for 1-bit. So reading a chart on device works, but it's the first place you'll feel the compression bite. They squeeze more speed out with speculative decoding, a lossless draft and verify pass. So you're not trading accuracy for the extra pace. The output is identical, it just arrives quicker. Small model, and still a few tricks left. Now the part the cloud vendors would rather you didn't dwell on. Once this model is on your device, the marginal cost of running it is zero. 100-step agent loop, 1,000 queries, an all-nighter, still zero. No meter, no token bill. And your data never leaves the machine. 0 bytes uploaded, because there's nothing to upload to. The prompt, the document, the photo, the answer, all of it stays on hardware you physically own. That's not a privacy setting. It's physics. This is the whole thesis of this channel in one download. You're not renting intelligence by the token anymore. You own a copy outright, Apache 2.0 licensed, yours to run, fork, and ship forever, with no one able to switch it off. It really is open. Apache 2.0 waits on Hugging Face, code on GitHub, plus a one-tap iOS app. No account wall, no waitlist, no API key. You just pull it down, and it's yours. Developers noticed instantly. The launch hit the Hacker News front page, 681 upvotes, 242 comments in a day, and topped Hugging Face's trending board. And it's not only developers watching. Apple is now in early talks to evaluate the tech. It's genuinely easy to try. 1. Grab the GGUF weights from Hugging Face for a laptop. 2. Clone the demo repo from GitHub. Or 3. If you just want to see it, install the Locally AI app and load Bonsai right on your iPhone. So step back and look at what actually happened here. A 27 billion parameter model, the kind that used to demand a server, now fits in 3.9 gigabytes and answers you with the plane in airplane mode. Now, let's be honest, and I won't pretend otherwise. 3 real catches. It's a quantization of Qwen 3.6, not a brand new model. Run it on a phone, and, like any small model, it'll hallucinate on obscure facts. And it isn't fast. And there's one number that genuinely drops. Agentic tool calling, the benchmark that matters most if you want this driving real workflows, falls from 80 at full precision to 74 for ternary, and down to 66 for 1-bit. That's the corner they cut hardest. The phone story has fine print too. A 12-gig iPhone only frees up around 6 gigs for a model, and Bonsai shares that with its context and working memory. So the huge 262K context is real, but on a phone you'll only use a slice. So here's the honest recommendation. Heavy tool use or agents. Run ternary on a laptop and keep more of that quality. Just want private chat and reading in your pocket, 1-bit on the phone is genuinely enough. Match the build to the job. Here's the do-it-today recipe. On a laptop, pull the 3.9 gig 1-bit GGUF from Hugging Face and load it in any Llama CPP front end. On a phone, install Locally AI and pick Bonsai. Airplane mode on, and it still answers. About 5 minutes. And that's the tell that it's truly local. Cut the Wi-Fi, cut the cellular, ask it to summarize a document or write a function, and the answer still comes. No signal, no server, no bill. Just your phone, thinking. That's the trade you're making. You give up a little accuracy, mostly on the agentic edge, and in return you get a capable model that's free to run, fully private, and can't be deprecated on you. For a lot of work, that wins. So to recap, 1. A full 27B model now fits in 3.9 gigabytes and runs on a phone. 2. It keeps around 90% of the original's ability, though agent tasks take the real hit. 3. It's Apache licensed and free to own. If you remember one number, make it 3.9. That's how many gigabytes it now takes to carry a 27 billion parameter model in your pocket. No GPU, no cloud, no permission required. The data center just moved into your hand. That's the brief. If this saved you from renting a model you could just own, subscribe back, and I'll break down one story like this every single day. I'll see you in the next one.